first problem is going to be a right triangle, and you're asked to find the hypotenuse. So they give you one of the sides, the y side, they give you another side. And of course you have to use Pythagorean. No, this is this problem right here. You have to use Pythagorean to solve it. Relatively easy. The next problem you should be doing would be probably 75, where you've got some aerogel. This stuff is great, aerogel, and it's 1/10 of a gram per centimeter cubed. That's 1/10 of a gram per centimeter cubed. Well, how big would that be? How much would it weigh if you had a cubic meter of this stuff? Well, if a centimeter cubed, again, the problem-solving technique says to draw pictures. So if I got 1 centimeter by 1 centimeter by 1 centimeter. Well, if I had a meter cubed, I would have 100 centimeters by 100 centimeters tall, and then it would be 100 centimeters deep. And that could be your cube. So how many of these pieces would I have? Well, it would be 100 by 100 by 100. And each one of those would have a mass of 0.1 gram per centimeter cubed. So that would be 100 centimeters by 100 centimeters by 100 centimeters. So that would be, let's see, 1 with 6 zeros behind it. And the phone's ringing. And that would be times 1/10 of a gram. So we lose a 0 there. So we've got us a bunch of grams. And the units on top would be centimeters cubed, grams. And underneath would be centimeters cubed. We lose the centimeters cubed, and that would give us 100,000 grams, or about 100 kilograms. So the solution would be 100 kilograms. The final question in section 1.7 you should be doing is number 77, but that deals with nutrition, and it asks some weird questions that are really, it's a conversion thing, but let's go to something a little bit practical. 79, it's a level 2 problem, odd, and so let's do that. A light year is the distance light travels in a year. If the speed of light, c, is 3 times 10 to the 8 meters per second, and we're looking for distance, you know, the time is equal to 1 year. We want to know the distance it travels, and so it's distance. If velocity is distance over time, then distance would be equal to velocity times time. So that would be the formula for distance, velocity times time. So we could find distance by saying the velocity, which is 3 times 10 to the 8 meters per second, times 1 year, times 365 days per year, times 24 hours per day, and times 3,600 seconds per hour. Seconds cancel out down here, years canceled, and we'd be left with meters. And it would be 3 times 10 to the 8 times 1 times 365 times 24 times 3,600. And your answer would be in meters. So that's how you would do that one.